Okay, we'll have a look at this. Mathematically calculated, the probability of getting 6 winning numbers in Lotto is 1 in over 3.8 million. Okay. Not very much really, is it? I didn't write it down as a decimal. Okay, so is that a priori or relative frequency or subjective? Hands up if you think it's a priori. Hands up if you think it's relative frequency. Hands up if you think it's subjective. Good, it's a priori. It is based on mathematics. Okay, it is the way it is. It's not an opinion, it's not based on historical fact. Okay, you feel lucky and estimate that the probability of winning Lotto is about 0.01. Okay, so who wants to tell me what that one is? Subjective, yeah. It's an opinion. Which is more accurate out of those two? A priori. No. We'd like to think so, but sadly no. It's been found that 80% of shoppers at a certain store spend less than $5 in a single purchase. The probability that a given customer spends more than $5 is 0.2. Okay, so is that a priori, relative frequency or subjective? Okay, hands up if you think it's a priori. Okay, hands up if you think it's relative frequency. And if you think it's subjective? Good, most of you got it right. It's relative frequency. And you can tell that. How did you tell? Yeah. Yeah, it has been found. It talks about stuff in the past, but it's not just someone's opinion. Oh, we've noticed that about 5%, 80% of them do this. Okay, now this one is actually a question as well, and this is based on stuff that we're quite aware of when you've got children. So you've got a popular high school, draws the names at random from a ballot to fill its vacancies. There are 20 pupils from primary school A and 30 from primary school B in the ballot. What is the probability that a child from school B is chosen? Okay, so what kind of thing is that? It's a priori, that one. Because yet again, it's based on numbers. The probability that a child from school B is chosen is 30 over 50, which equals 0.6. Now, if they drew 5 names out of the ballot, and all of them came from school B, would that mean that the ballot was rigged? No. Good. It doesn't. And in fact, that's what we're going to be talking about next week, is using the binomial distribution. You could work out what is the probability that all 5 of them did come from school B. It is perfectly possible. However, if you took out 10 and all of them were from school B, you would start to wonder, would you not? Because there's something funny going on there. 10, when there's only a chance each time of 0.6, it's getting a bit dodgy. So, and that is basically the whole idea behind inferential statistics, and that's what we're leading up to in this course, is that in inferential statistics you get a result from a sample, and you want to know from that, does that mean that what I think is true, or have we got evidence that there's something funny going on here, that this is not actually right? So that is the whole idea behind inferential statistics.